Okay, so in this problem we have ammonia reacting with oxygen to form nitrogen monoxide and water. This is basically a combustion reaction. Keep that in mind when you need to go and balance it in a minute. So in this question we are given the fact that 3.25 grams of ammonia are allowed to react with 3.50 grams of oxygen. The questions, of course, are going to be, what is the limiting reagent or reactant, how many grams of the product NO are formed, and how much of the excess reactant remains after the reaction is complete. All right, so go ahead right now and balance this equation. Should have gotten 4, 5, 4, 6 for your coefficients. Again, that one was a little bit tricky. If you use the hydrocarbon trick, like we do for combustion, then would have made it a little bit easier. So we have our two starting values now, 3.25 grams of ammonia and 3.50 grams of oxygen. So let's see, ammonia is in grams. Again, my goal is to get to moles. So I can get to moles in one step using the molar mass. Right, so the molar mass of ammonia, 17.03 grams. Now I am in moles, oops, back up. Now I am in moles of ammonia, which means I'm ready for my magic step, right? I can use the mole ratio to go from moles of ammonia to moles of NO. So now I've converted my ammonia into my NO. Now that I have my NO, I can use the molar mass in order to understand what mass of NO will be formed from the 3.25 grams of ammonia that I started with. I'm going to do the same process for oxygen. So tell me what you get for oxygen. You should have divided by the molar mass to get moles, then used our magic mole ratio to go from oxygen to nitrogen monoxide, and then again used the molar mass of nitrogen monoxide to get a final value of 2.63 grams of nitrogen monoxide. Okay? So the fact that the oxygen produces less of the nitrogen monoxide means that oxygen is the limiting reactant. Once the oxygen is used up and 2.63 grams of NO have been formed, there's no more oxygen left to react. So we will never get to the 5.73 grams that the ammonia would have given us, right? Because we will have run out of oxygen before then. So that means that we will be able to make 2.63 grams of nitrogen monoxide. So our last question left over is how much of the ammonia is going to be left over. Okay, so give that a try. Tell me set up your example and tell me how much ammonia is going to be used up in this reaction. So you should have had this set up starting with the 3.50 grams of oxygen, converting that into the grams of grams of ammonia that are needed to react with it. So 3.50 grams of oxygen requires 1.49 grams of ammonia to react with it. Okay? So let's wrap this up now. We know that oxygen was our limiting reactant. Sorry, there's our problem again. We know that oxygen is our limiting reactant. We know that 2.63 grams of nitrogen monoxide could be formed. And our question to how much nitrogen ammonia is left over can be answered by subtracting the amount that we started with from the amount that we need to use up in the reaction. So that's going to leave us with 1.76 grams of ammonia left over. Okay? Now, it's up to you to, of course, practice, right? So putting these ideas together, lots of dimensional analysis, adding on that concept of which one is going to run out first, which one's going to be my limiting reactant. That's going to be the key to these problems.